What's up, YouTube? Welcome back to another episode of my devlog. In this video, I'm going to go over the changes I made to the weapon recoil and aiming system. So let's get into it. Alright, so the first thing I did was add in a rotation to the camera when you shoot. So it looks like this. And you have to pull down the mouse. And then the other thing I added was a little bit of movement to the gun holder. So if you see the gun is moving up and down, and then it's a very subtle change, but it speeds up when you walk, and then should speed up when you're running. Yeah. And idle, should be back to normal. So first I'll go over the scripts that pertain to the weapon hold movement. So you see here I have the weapon recoil script. If I'll scroll down to what I originally had, this is just the Lerp system that moves the gun back and forth when you shoot, if this all looks familiar. So I added a few things to this script. First things first, I grabbed the mouse look script, and then I have a list of floats here that are going to determine how much rotation, upwards rotation is applied to the camera, and each float is specific to each gun. So you see here we have the Ithaca, AA, Glock, and so on and so forth. And then these floats are all going to be set inside the inspector. And then to determine which float is going to be used, we grab all of the weapon hold locations. So you see we have Ithaca hold location, AA, and all the way down. And then in the and then this is just grabbing the weapon hold locations via tag. And then down here in the update method, we have an if statement that checks to see which weapon hold locations have a child, meaning that specific gun is equipped. So you see here we have if Ithaca hold location dot transform dot child count is greater than 0. So if the Ithaca is equipped, and then also we check to make sure that the hold location is active in hierarchy, because we have primary and secondary weapons, and when one is equipped, the other is turned off. So we just need to make sure that we have the primary equipped in this case. And then inside this if statement, we have two more if statements that just check to see if we are aiming or not. So if we're not aiming, mouse look script dot up recoil is going to equal the Ithaca camera recoil float. And if we are aiming, I just wrote a simple equation. I just take whatever the recoil is and just divide it by 2. So you see mouse look script dot up recoil equals Ithaca camera recoil divided by 2. And then same thing down here. If we're not aiming, it's the AA camera recoil. And then down here, if we are aiming, we just take the AA, divide by 2. Pretty simple. So now if we scroll down to the Lerp function, again here we have lerping back and then lerping forward back to the original position. I have this one line written here inside the first Lerp function that reads mouse look script dot gunshot recoil. So we're calling a method inside the mouse look script. So now if we jump into the mouse look script, you see here we have the gunshot recoil method, and I basically just take the X rotation and add the recoil to it when this gets called. And then again, this variable here is going to be determined inside the updated weapon recoil script. And now to show you the FPS weapon movement, first I will show you where I have the script located in the hierarchy. So if you take a look here, this is our player. We have camera parent, main camera, and then underneath that we have the gun holders, and the primary and secondary sit underneath that. I have the FPS weapon movement on the gun holder script, so it's going to move both the primary and secondary, and knife hold and anything underneath it. And now we do have a few variables set up. So first things first, well, this is all the Lerp information, you know, same as all the other Lerp scripts that I have. But the thing here that's a little different is we want to determine a different speed based on whether we are standing, so idle, walking, or running. So you see here, this is the main float Lerp speed, and that's going to be equal to one of these four. So we also have a Lerp aim speed. So we have Lerp aim speed, standing Lerp speed, walk Lerp speed, run Lerp speed. Oh, and I also duplicated these three so I can change the down speed and up speed independently. So so you see here we have standing Lerp speed down, and then here it's standing Lerp speed up. As I've mentioned in previous videos, I prefer it that way whenever I'm lerping from point A to B and then back or to another position. I like to be able to control the duration independently. And I know you know that may not be something that you need to do all of the time. I mean, you definitely don't. But I feel like this is a perfect example on why I prefer to just set it up this way. So the way this system is, it basically takes the original position, which is right in the middle of this movement, and then it's going to lerp down to position B, I guess you can call it, and then it's going to lerp up above the original position to a third position, C, and then it's going to go back down to position B. So basically, if this makes sense, the distance from the second position to the third position is going to be greater than the distance from the original position to B position. So to try to match the speed up as much as possible, you're going to want a shorter duration from or shorter duration time from point B to C. So now below this we have the float for how much we're gonna move. So I have public float, move distance X, move distance Y, move distance Z, and in this case it's just gonna be the Y axis. And then down here we have 4 bools. So if we're moving down, if we're walking, running, or aiming. Okay, and then this is here the vector 3 positions as I mentioned before. So we have the start position, which is the original position in the middle, and then down lerp position, and then up lerp position. and then current position, which I don't know if I'm using. Okay, no, yeah, I am. And then I'm actually not using this. Okay. So now in the start method, we're going to set the moving down bool to true, and then walking is false and running is false. And then start position equals transform.local position. That just grabs the initial position of the object. And the reason why these two are set to false is because we're initially idle, not moving yet. So now the down lerp position is going to be the start position plus a new vector 3. And again, we're just going to be, we have written out move distance x, move distance y, and move distance z. And then these variables are set inside the inspector, and we are only moving along the y-axis. So we take the start position and we add a negative movement, so it's going to go down, right? And then up lerp position is going to be the start position, and we're going to go up. All right, so now you see how the up lerp position is higher than the original position. Hence why going from position B to C is going to be a greater distance. So now in order to determine whether we are standing still, walking, or running, or aiming, we have to use both the player walk script and the weapon aim script. So I'll start with the weapon aim. If you take a look here, you'll see I added in the script, FPS weapon movement. And now if we are aiming, so let's see right here, input.get mouse button 1. So that's the right mouse button. Aiming is set to true. And then we're also going to take the FPS weapon movement script and set the aiming bool inside that to true. And then if we get mouse button up, so if we let go, aiming inside this script is set to false. And if we're not aiming, we take the FPS movement script and set that aiming back to false. So now if we jump back into the FPS weapon movement script, you'll see here we have an if statement that reads if aiming, and then we set walking to false and running to false, just so that we don't have any conflictions. But we set the lerp speed to lerp aim speed, and again, this variable is set inside the inspector. Alright, and I realized when I set this up, I actually designed it so when you aim, the gun is not moving up and down at all. So if you look down here where we have the lerp function, transform.local position equals vector 3.lerp, we take the current position, so wherever it is, we return to the start position, and then percentage complete. Alright, and now if we jump into the player walk script, let's see. Alright, so here we have the FPS weapon movement script. And now inside the update method, we have these two if statements that determine whether we are sprinting or not. So we actually need to switch this. If we are sprinting, walking is false, and sprinting is true. Okay. Alright, so if we are not sprinting, FPS weapon movement script dot running equals false, and walking equals true. And then if we are running, walking is false and running is true. And this is I should have mentioned this first, but this is inside a another if statement that reads if input.getKey. So if we're pressing either the A, W, D, or S, we are walking. And within this script, what determines whether we are sprinting or not is the shift key. So shift is the button to sprint. So yeah, we have here if input.getKey up, key code.left shift. Oh, that's to stop sprinting. If can sprint and input.getKey, key code.left shift, and input.getKey. So if we hold the left shift and we are walking forward, we're sprinting. And then get key up, left shift, we stop sprinting. So yeah, once again, this is how it looks. See, it speeds up a little bit. I realized at the start of the video, I don't think it was working 100% correctly because I had the I had to switch around the bool statements, but it should be good now. Let's see. Yep. All right. Oh, and the other thing worth mentioning is I added in when you aim, the camera FOV changes. So you see here, zooms in a little bit. Yep. So this was pretty simple as well, just another Lerp function. So you see the if statement on the weapon aim script for if we are aiming. Scroll down, you see camera field of view. Again, just another Lerp function. So we have camera.field of view equals mathf.lerp, camera.field of view. So whatever the initial field of view is set to. So you see here, camera field of view equals camera.field of view. Same thing as, you know, if you're finding transform.local position of an object. And then we change the camera field of view to 40. So I think it was initially at 60. We change it to 40. And then the duration or speed. And then if we're not aiming, we lerp back. Yeah, so it was 60. So camera.field of view equals mathf.lerp. Camera.field of view. So whatever it currently is, and then 60 and duration. Okay, and that is pretty much it. Just some simple changes, but necessary. You know, it's little things that you add in that help improve the game feel, which is obviously super important. So yeah, hopefully this video helped anyone that's trying to create the same setup. Thank you again for watching, and stay tuned for more.